Alright, today we're doing 5-4 and we're talking about polygons. And a polygon is going to be a closed plane figure formed by 3 or more segments. And then the name is by the number of sides. So we look at this table. This is a very good example of different types of polygons. So you can see that we have a triangle here, and that's with 3 sides. A quadrilateral has 4 sides. Pentagon has 5, hexagon has 6, heptagon has 7, octagon has 8, and anything greater than 8 we call an n-gon, which just symbolizes that it has more than 8 sides. So if we look at here, we can have some examples. Here we have a quadrilateral because we have 1, 2, 3, 4 sides. Here if we look, we have 1, 2, 3, 4, 5 sides. So if we look here, that is an example of a pentagon. See if you can make an example of a hexagon. You should have come up with something like this. Something that has 6 sides. Now notice how all of these are closed. What that means is there is no shapes that are left open like this or that have a gap right here. That is what we do not want, is something that doesn't have, that's not closed. Alright, what we're going to do here is we're going to try to find the sums of the angle measures. And what you always want to do is cut your polygon to make triangles. So if I start at this corner right here, it's already being connected to this point right here as well as to this point. So the only other point that we can make a line to is, remember, each triangle is 180 degrees. So all we have to do is, since we have 2 triangles, one here and one here, we can do 2 times 180. And that will give you 360 degrees. So the sum of the angle measures of a quadrilateral is 360. Okay, now let's try a hexagon. So a hexagon has 1, 2, 3, 4, 5, 6 sides, and it makes 1, 2, 3, 4 triangles. So we're going to do 4 times 180 degrees. And 4 times 180 degrees. See if you can figure that one out. So you should have gotten 720 degrees. Let's see if we can find a pattern. If we go back and look at the first one, we had 4 sides and 2 triangles. In the second example of our hectagon, we had 6 sides and 4 triangles. Do you see a pattern? Let's see if that holds true for this third example. This third example is a heptagon. It has 1, 2, 3, 4, 5, 6, 7 sides. How many triangles does it make? 1, 2, 3, 4, 5. 5 triangles. So without having to create your vertice every time and pointing to how many places it goes, all you have to do is the number of sides minus 2 times 180. So for an example 3, we could do 7 minus 2 times 180. And 7 minus 2 is 5. 5 times 180 is 900 degrees. So why don't you try one on your own? What if I give you a pentagon? This is 5 sides. What would be the sum of the angle measure? See if you can figure it out on your own. So what you should have done is 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180 is 540 degrees. Okay, so now what we're going to do is find the angle measures in a regular polygon. So we want to find this inside measure. So if we look here, you notice how all of these angle measures are the same. So we can say x plus x plus x plus x plus x equals. Now in the last examples you were finding the angle measures, the sum of it. So all we have to do is combine that step with the step we just did. So remember, we take the number of sides, so here we have 5, subtract it from 2, and multiply it by 180. Now let's simplify this expression. Remember, there's ones here, so we can combine all these to get 5x equals, well, 5 minus 2 is 3, so 3 times 180. So let's go ahead and solve that. Well, 180 times 3 is going to be 540, and we have 5x over here. Now you know how to solve this. We want to get x alone, so we need to divide both sides by 5. So the measure of x equals 108 degrees. And to do a check, you can do 5 times 108. And let's see if that equals 540. And it does when you do your check. So see if you can do B on your own. So what you should have done is we should have noticed that there are 1, 2, 3, 4, 5, 6, 7, 8 y's. So we could have done 8y equals, now the number of sides we have are 1, 2, 3, 4, 5, 6, 7, 8. We have 8 sides, so we need to do 8 minus 2 times 180. Let's simplify this a little bit. Let's leave this as 8y equals 6 times 180. Well, 6 times 180 is 1080. Now let's divide both sides by 8, and y equals 135 degrees. So each interior or inside angle is 135 degrees. Okay, this next part, this next diagram is going to be super important to help you classify. So we're going to use this to classify quadrilaterals. And if we're thinking quadrilaterals, we're thinking 4-sided figures. Okay? So if you notice, in all of here, all of these shapes have 4 sides. So we can break these down. So let's start with trapezoid. A trapezoid is going to have one pair of parallel sides. So you'll notice here in the diagram that they give you that we have a set of parallel lines right here, top and bottom, and on this figure they're on the side. So if you see any figure that has at least one pair of parallel sides, it is called a trapezoid. The next one is a parallelogram, and that's when you have two pairs of parallel sides. So this top and this bottom are parallel, as well as the sides. That is true for all three of these shapes. So a trapezoid does not classify as a parallelogram. If you look in this diagram, we can classify parallelograms even further. Let's go to a rectangle. Notice that these sides on this rectangle, all of them are parallel. But now we can go one step further and say that we have 4 right angles. So not only are we having parallel sides, but now we have those right angles in there. The next one that we can talk about is a rhombus. A rhombus is just going to have 4 congruent sides. So you can still see that we have those, that all of our sides are going to be exactly the same, but they're not necessarily always parallel to one another. And then finally, we can talk about a square. And a square is going to have 4 congruent sides and 4 right angles. So it's combining the rhombus and the rectangle together to give you one shape. So this is going to be really important to help you with your homework as well as in the next activity. Alright, what we're going to do is we're going to use that diagram from before to help us classify each of these polygons. So if we look, right away we know that there are 4 sides. So we can say that this is a quadrilateral. Now let's go through those definitions. Let's start with trapezoid. It tells you right here. Okay, if we also look, this is telling us that EF is parallel to GH. So we know that we have one set of parallel lines, and that would classify this also as a trapezoid. Now if we go back, trapezoid does not fit into any other category, so we would stop there. That's all that it could classify as. So let's try this second one. See if you can find the categories that this second shape fall under. Okay, what you should have come up with is quadrilateral, because again, it has 4 sides. We also see that we have these 90-degree angles, and we also have parallel lines. So we have a parallelogram. So if we have 2 sets of parallel lines like we do, that makes it the parallelogram. Now these 90-degree angles also mean that it is a rectangle. We would stop there because it would not fall under a square or a rhombus. So at this point you can now do your exit slip.